This is 2.6, Modeling with Functions, and this is Day 2 Notes. An open storage bin with a square base and vertical sides is to be constructed from 108 square feet of material. Determine the box's dimensions and its volume to be maximized. Okay, so we're looking at volume, and I want to maximize at the end. So it looks like we've got an open box, square base, vertical sides. We've got 108 square material. That is surface area. All right, let's look at a box here. So we can try to draw one. Okay, we know that the box is open. That's important. We've got a square base. So let's see what we can work with here. If we've got a surface area of 108, let's give this box some dimensions. If we've got a square base, let's give the base the same dimensions and the vertical side a different one since we don't know what it is. Let's call that our height. Okay, so surface area, how about we say we've got one base, so that would be x squared. We have an open box, so we're not going to add that. Now let's add all our sides. So our sides are going to be x times h, and we do have 4 of those, so I'm going to add 4 x times h's. That's going to be our surface area. That's going to equal 108. I do want to get to volume, which is a side squared times h, since we have a square base. So if our side squared, looks like we're going to have to solve for h. So let's go ahead and do that. If I solve for h, that is going to be what? 108 over, 108 minus x squared, sorry about that, over my 4x. Now I can plug that in. So instead of s squared, how about we change that to x squared, since that's what I've got. And my h is going to be 108 minus my x squared over 4x. And go ahead and simplify your x's if you would like to, or you can go ahead and go straight to your calculator and find your maximum. Again, you should have a parabola because you have an x squared here. So in order to find the max, I found a max of 6,108. So what does the 6 represent? That is going to be your base of 6 and 6. So I've got 6 feet by 6 feet. And our height, in order to get a height of a surface area, of 108, then our height is going to have to be 3 feet. Okay, looking at the next one. This is totally made up, however. Let us believe that it takes twice as much energy for a plane to fly over water as it does over land. We are flying into a city, and we are currently 100 miles from the nearest mass of land, and the city is 250 miles down the coast from the nearest point on land. Okay. To what point should we fly in order to minimize the total energy expended in traveling to the city? Okay, so you've seen this drawing before. Let's look at this. We've got a right triangle, and it says that it's 250 down the coast. So this is our coastline here, and I'm going to say that it's 250 down the coastline. It says 100 miles from the nearest mass land we are flying. So I'm going to label this as 100. All right, so we need to start giving some information. So it looks like our water is out here, and our land is, of course, here. So it's going to take twice as much energy to fly over the water as it does land. So twice as much energy over the water as it does to go over the land. So finding the information, if this is 100, this is 250, let's label this as your x, and this is 250 minus x. And finding our right triangle information, this would be 100 squared plus x squared, and we're going to take the square root. Okay. Now we can go ahead and set up an equation to minimize the total energy expended traveling in the city. Or to the city, I would say. So we're traveling here over the water, and then to the land, to the city. Okay, so I would say the distance is twice over water. Remember, this is over water. So I'm going to say twice times 100 squared plus x squared. And I'm going to add that to going over land, and that would be 250 minus x. Okay, I would just plug this into my calculator, into y1, and find my minimum. I found a minimum of 57.735, comma 423.205. So it looks like my x value is what I'm actually looking for. So that would be 57.735 miles down the coast. All right, let's look at the very last problem. It says you are standing at the edge of a slow-moving river, which is 1 mile wide. You know that it is dinner time because you smell the yummy hamburgers on the grill at your campsite across the river. You can swim 2 miles an hour. You can walk 3 miles an hour. You must first swim across the river to any point on the opposite bank, from where there you must walk to the campground. So you've got to do both, which is 2 miles from a point directly across the river. So you've got 2 miles across the river, where you start to walk, where you start to swim. What route will you take the least amount of time, and how long will it take to get to dinner? Okay, I'm going to go about this with the same picture that I just drew, because I have to walk and I have to swim. So swimming and walking. So this is going to be the river, and this is the land. So let's see what we know about this. We know that, there it is, 1 mile wide. The slow-moving river, which is 1 mile wide. So the river is only 1 mile wide. And we have to do 2 miles directly across the river from where you start to swim. So here, we have to walk 2 miles. So if this is 1, this is 2, let's label this as your x, and this is 2 minus x. We can go ahead and find this hypotenuse, which would be 1 squared, or 1 plus x squared. Take the square root. So we have all our information. Okay, they did give you some more information, though. They told you that you could swim at 2 miles an hour and walk at 3 miles an hour. So I'm going to use the formula D equals RT. And I'm going to use that as a swim and as a walk. So we have to do both of them to get to our campsite. So the information I know is if I swim, this is the swimming one, I know my distance is 1 plus x squared. And then that's the square root. I know my rate is 2, but I don't know my time. Same thing with my walking. I know my distance is 2 minus x. I know my rate is 3, but I don't know my time. I also know that I have to do these together in order to get to my campsite. So I'm going to solve these for t. So t would be equal to the square root of 1 plus x squared over 2. And this would be equal to 2 minus x over 3. And I'm going to add those together to be equal to my total time. So t is equal to 1 plus x squared over 2 plus 2 minus x over 3. And that should be equal to my total time. Plug this into your calculator and find a minimum. So I want the least amount of time. The least amount of time should be 0.894, comma 1.039. And what this represents is that you can swim 0.894 miles and it will take 1.039 hours. Okay, bring questions to class.